here, I want you guys to keep this chart in mind, okay? Hybridization is just simply orbital math. So you know when we talk about math, right? We're talking about in terms of when you talk about hybridization, all you're going to do, guys, is just look at your electron groups and the shape of what it is, and then match it up to the hybridization. It is not difficult at all. If you look at the fact that this says electron groups, right? It says 2. Well, look at this. You have 2 sub-levels, right? S and P. That's a total of 2. I always look for patterns, okay? I look for patterns when I'm trying to memorize this stuff. Because sometimes you may come across a professor that doesn't want to give you a cheat sheet. You may have a professor that says you have to memorize this. So what better way than to look for a pattern? Whatever works for you, do you, okay? So for this particular one, if I say you have 3 electron groups, it's going to be trigonal planar, but the hybridization is sp2. Again, look, what's 2 plus 1? That's equal to 3, and that's how you got your electron groups. Look at tetrahedral. There are 4 electron groups. Basically, we're saying 4 bonds, okay? So whenever it says electron groups, we're talking about the number of bonds also, okay? That's right. It happens over here too. Yes, yes, yes. When you get to tetrahedral and it tells you that you have 4 electron groups, then check this out. sp3 will be the hybridization. What's 3 plus 1? 4. All right. 4. So now, if you take a look at this next part right here, Trigonal Bipyramidal, you have 5 electron groups, therefore you have sp3d. What's 3 plus 1 plus 1? 5. So as you all can see, this is the pattern here, okay? Now, I'm going to also go over sigma and pi bonds, but first, let's make sure we can conquer this whole concept of what we were discussing just now, okay? Now, we did draw these images yesterday, okay? And because we drew the images yesterday, what I want you all to do, we're going to go back and look at some of these pictures. And when we go through the pictures, we're going to answer the questions in terms of hybridization. So I'm going to put some random ones here so we can use our chart. All right, so let me show you all how to actually draw this out, right? So let's just go to some of our basic ones that we've dealt with before. Let's start off with hydrochloric acid, HCl. Okay, now when you draw this out, all right, I'm just going to draw the image out so that way we can just get straight to the shapes, okay, and the hybridization. Right here, you will notice that it's just 2 elements, right? The easiest thing I can tell you is that when you have 2 elements, it's going to be a linear shape. Now, when we go back here, though, and look at our chart to determine the hybridization, if you look here for a linear shape, it tells you it is sp hybridization, okay? sp. Now, I'm all about looking at patterns, as I told you before. Okay. And when I look at patterns, this is the thing I want you all to keep in mind, and so that it's easier for you to remember this, okay? Let me zoom in so you all can see this. It starts off as sp. This kind of resembles electronic configurations to a certain extent, okay? sp, sp2, sp3, sp3d, sp3d2. Y'all, it's just 5 of these that you have to remember, okay? Just 5. So when we go through these examples, hopefully this will make sense to you in terms of not overthinking this process, okay? So if I do another one, all right, let me show you another example. All right, I'm going to do NH3, all right, NH3. And I'm going to show you all. We're going to walk back through each of them so you can see the pattern, okay? So I'm going to draw them here and scroll down below. All right, so here we go. Right now, if we are looking at, let's say, carbon dioxide, right? CO2. Well, If you've had chemistry or if you're currently in chemistry now, this should all make sense to you. I'm just going to do the math because I know some of you all are like, wait, what? What are we doing here? All right, so you've got your 1 carbon, 2 oxygens. Carbon is in group 14. That's where the 4 comes from. So you drop the 1 and you get 4 valence electrons. Oxygen is in group 16. You drop the 1, that's where the 6 comes from. But you have 2 oxygens, so 2 times 6 is 12. Now, when you add them together, you get 16 valence electrons. Now, what I want you all to do here is to look at the pre-math work, which means I've got my carbon atom right here with the 4 valence electrons, and then I have my 2 oxygens. We're going to actually put this together, and then when we use them, we're going to X them out so that we can know which ones we've actually used, okay? This is like our way of seeing, all right, what it looks like before we put the whole thing together, all right? Now, I'm going to start off with carbon in the middle, and it's going to be surrounded by those 4 valence electrons that it has already. Now, I'm going to go ahead and check that off, and now I'm going to draw in my oxygens. So I have 2, 4, 6 around the left side of that oxygen. I'm going to cross that one out now. And I've got my last oxygen coming in right here. So that's 2, 4, and 6. Now, here's what I want you all to think about. When you look at this particular molecule right here, you have to remember that anything in groups, and let me write this down so you all can see this, okay? Groups 14 through 17 must have 8. Groups 14 through 17, they must have 8 around the central element, okay? The center element must have 8. So when I look at carbon, carbon is a part of group 14. Each of the oxygens are a part of group 16. But here's the thing though. Right now, carbon only has 2, 4. But look at each of the oxygens. Each of the oxygens has 2, 4, 6, 8. 2, 4, 6, 8. Carbon is in the middle complaining that it does not have the 8 that it needs. So what is it going to do? It's going to pull from one side of your oxygens. It doesn't matter which one you do, just choose either side. I'm just going to go with the right side. Since it's over here, I'm going to erase these 2 on the top, and I'm going to drag them basically right here to the middle. See? But I still have 8 valence electrons on oxygen right here. Let me show you. See, 2, 4, 6, 8, because they're being shared, but the carbon still has less than 8. Carbon in the middle has, let's count it, 2, 4, 6. So guess what? The oxygen on the left over here needs to contribute the 2 from the top to the middle right there. So now carbon is satisfied. And oxygen did not lose anything because they are still sharing. So you've got 2, 4, 6, 8 for the carbon in the middle, 2, 4, 6, 8 for the oxygen on the right, 2, 4, 6, 8 for the oxygen on the left. Now, the last step in doing this process is to count everything to make sure that you have 16 total valence electrons in your picture. And if we go and count them, we have 2, 4, 6, 8, 10, 12, 14, 16. Everything checks out and we are good. But I'm going to also redraw this structure here by replacing the dots in the middle with dashes. So I'm going to replace these pairs here as dashes, okay? So here we go. This is 2 right here and 2 right there. Now, the element in the middle has 2 bonds attached, which is basically the oxygens. There aren't any lone pairs of electrons. Lone pairs meaning the 2 that are hanging out at the very top or at the very bottom. There aren't any. So because you have 2 bonds attached, 0 non-bondings, let's see what our shape is according to what we just did. All right. So if we go down here to our chart and we look, it tells us that we have 2 bonds, 0 lone pairs. This is a linear shape. So my shape is linear. Now, in terms of the hybridization is going to be sp. So that's your sp hybridization. Okay? That's how you do these problems, guys. This is, when I tell you all, it is not a difficult task. You just have to slow down, okay? Slow your mind down. And next thing you know, you got it. You are so welcome. You are welcome. All right. Let's do another one. Let's do another one. Remember, my goal is to give you confidence, okay? I want to make sure that all of you can do this without any hesitation. All right. So now let's do another one, okay? Let's do, I want to show you one where you have a double bond. Well, let me show you what I mean, okay? So let's do C2H4 right here, C2H4. NO2, we'll try that one next, okay? We'll do N, let me write that off to the side over here, NO2. All right, so you've got C2H4, right? See that? Let's break it apart. You've got 2 carbons, 4 hydrogens. Again, we're going to multiply them times their respective numbers of valence electrons. So we've got 4 valence electrons, 4 carbon, but you have 2 of them, so 4 times 2 is 8. We have 1 valence electron per hydrogen, but you have 4 of them, so 4 times 1 is 4. You're going to multiply those together and you get this. Now, you got 8 plus 4, that gives you 12, right? Here is the bookkeeping. Here is the bookkeeping. You're going to draw each of these molecules, 1, 2, 3, 4, 1, 2, 3, 4. So that way we know that when we are done using it, we can just check it off, okay? So here we go. In the middle, we're going to start off with the first carbon. 1, 2, 3, 4. We're going to put the next carbon. Oh, let's go ahead and cancel that out right there. We use that. Here comes your next carbon right here. That's 1, 2, 3, 4. We're done with that one. Let's now add our hydrogens. You have 4 of them. So here comes your first hydrogen. You can either put it on the left or the top. Tomato, it doesn't matter. So here comes your first hydrogen, plus 1. Cross that out. Here comes your second hydrogen, plus 1. Cross that out. Here comes your next hydrogen, plus 1. Cross that out. Here comes your last hydrogen, plus that 1. Cross that out. Yes, it's the 2 is only the subscript for carbon. That is correct. No, you're good. You're good. You're good. Now, remember why I said it didn't matter whether you put the hydrogen on the top or the bottom? Here's why. Let's zoom in so we can see even further. Here's why. These 2 are left alone by themselves. You see these 2 on the bottom right here? They are left alone. So whether I had them on the top or the bottom, that picture was still going to look like that. So what do? We're going to move them to the middle. Okay? We're going to move them to the middle right in here. So I'm going to erase the two that are on the bottom, and I'm going to join them to the middle, because you cannot leave them solo like that by themselves. And as I said before, and I say this all the time, those things that are left alone are like children. You leave them by themselves, there's a room for disaster. So I took the two that were left at the bottom and I moved them to the middle. Now, let's go back and make sure that both carbons must have 8. 2, 4, 6, 8. The carbon on the left has 8. 2, 4, 6, 8. The carbon on the right also has 8. Therefore, you're good with the carbons. The hydrogens don't need 8 because they are giving their electrons away to the carbon atom to ensure that it has 8. Hydrogen also has a positive charge, therefore it can donate that charge, and it's donating it to carbon, which needs it. Now, we're going to also count up our little dots to make sure they're equal to 12, because that's what we need. Sometimes when you do this, you're going to end up realizing, hey, I miscounted. What happened? So let's recount. You have 2, 4, 6, 8, 10, 12, and they add up. Okay? They add up. So now I'm going to replace those little dots here with dashes, because remember, we don't want to leave the image like that, okay? We do not want to leave our image like that. So what we're going to do is draw the dashes in the middle for that double bond, and the single bonds are right here, okay? Now, this is going to play a role when we get into sigma bonds and pi bonds, because you've got to understand what this represents, okay? And we'll get into that momentarily. Now, right now, we're trying to determine the shape. So this element or this element technically is in the middle. Either one is in the middle. If I look at this carbon here, how many bonds are attached to it? 1, 2, 3. Do you see any non-bonding pairs of electrons on that? Absolutely not. How many bonds are on this carbon on the right? 1, 2, 3. Do you see any little lone pairs dangling about? Nope, you do not. So because I see 3 bonds coming off of carbon, 1, 2, 3. And remember, double bonds do not count as double trouble in terms of double elements. No, double bonds just represents instability, okay? Unstableness. Side note, that's a side note. We're just only looking at the number of elements popping off this middle element. And there are 1, 2, and 3. So since there are 3 bonds and 0 non-bondings, guess what? This is trigonal planar. Trigonal planar. And because this is trigonal planar, watch this. It has sp2 hybridization, okay? So let me zoom out and write this again. So those of you all that are taking pictures of this stuff, you will know the answer, all right? It has 3 bonds, 0 non-bonding. Therefore, this is trigonal planar. Also, in terms of the hybridization, it is sp. Okay? Those are the things you would have to know. This type of question should only take you less than 5 minutes. Let's do it. You have to look at the middle element to determine how many bonds. So right here, this is a middle element, and I'm going to highlight what's attached to it, okay? 1, 2, 3. That's what's attached to that yellow one. Let me zoom in. Okay? We're going to do the NO2. Let's go ahead and erase this one, okay? Because I know that you all have questions about other types of bonds. And y'all, we're going to do a triple bond too. We're going to do a triple bond as well. And then we're going to switch gears to answer. We're going to do a quiz because I do have some quiz questions for you. So we have NO2. Check it out. Nitrogen, oxygen. We're doing the math. Y'all know how we do this. We have one. I already see a problem. We have one nitrogen times 5 valence electrons. Because nitrogen is in group 15, which means you have 5. We have 2 oxygens, and each of them is going to contribute 6 valence electrons. So 2 times 6 is 12. Here is the problem. Houston, we have a problem. Whenever we see that there are an odd number of valence electrons, that tells me that there is a free radical running rampant, okay? It's running rampant. It's like, wait a minute, let me go start some trouble, okay? And so, in order to do this, either we can go ahead and note that there's a problem here with the free radical. And if it's a free radical, that means it's going to be an unequal sharing of electrons, okay? Valence electrons. I'm going to draw the picture so you all can visually see what I mean about us having a problem. You've got nitrogen. Let's do our math over here. Nitrogen is going to come in with 5 valence electrons. And then you've got your 2 oxygens. So this is our bookkeeping over here. We're just pre-drawing them so we can cancel them out once we've used them. So nitrogen is coming in with 1, 2, 3, 4, and 5. Oxygen, 2, 4, 6. The other oxygen, 2, 4, and 6. Right now, you've got 1 that's at the top, and that 1 is a problem, okay? This is a problem. However, we could also say, well, you know, free radicals do occur. That just means something's not good. But what I also know that this could also be redrawn out as NO2 with a -1 charge. And this is one of those polyatomic ions, okay? This is one of those polyatomic ions that you could draw out and put the -1 at the very top, all right? So this could be either a mistake for somebody, or as a teacher, I would say determine the problem in your molecular geometry shape. This is not workable, okay? You can't do anything with this. So I'm going to repair this by saying that maybe the student left off a -1, okay? But in this case right here, because you put the -1 there, because this is a polyatomic ion, in chemistry, whenever it's negative, we're going to make it positive by adding an extra valence electron to give us 18, right? So check it out. We're going to end up adding that extra one right there. But we ain't done. We're not done. You're going to check to make sure that the element in the middle must have 8. 2, 4, 6. It only has 6. So nitrogen is complaining. Meanwhile, each of the oxygens has 8. So what you're going to have to do is tell one of the oxygens to give up 2 to make nitrogen have the 8. So I'm going to take 2 away from the left, and I'm just going to put them right there in that side. There you go. So right now, nitrogen has 2, 4, 6, 8. Nitrogen says, all right, I'm good. However, If the other oxygen happened to say, I'm gonna give you two of mine too. Let me show you the problem you would have. Look, you would end up with 2, 4, 6, 8, 10. Two too many. So therefore, you would have to go back and revise this problem. So you don't want to have more than 8 in the middle. Matter of fact, 8, like I said before, is the magic number. So therefore, you got to take those two and run it back to the oxygen that was on the left side. All right? Now, well, Mink, let's establish the shape. Yep, we're going to get to the shape now. Now, for this one, guys, what we're going to do, we need to redraw this, but we need to replace those little dots in the middle, those valence electrons. We need to replace them with the bonds, with the dashes. So you have a double bond and a single bond. And we're going to put this entire formula here in brackets with the negative charge on the outside. Let me see if I can move our structure over. Okay. Oh no, hold on. I'm going to move that off to the side over there. Okay. So that way you all can see I moved that over there. And in case somebody forgot, let me put that over there, 18. And on the outside of this bracket, we need to put the negative sign, because that's going to show us that we had to add an extra valence electron. Now, let's get into the work of the shape. We have how many bonds popping off of nitrogen? How many bonds are coming off of nitrogen? 1, 2. How many non-bonding pairs of electrons are coming off of nitrogen? 1. So 2 bonds and 1 non-bonding, okay, tells us this shape down here. Let's figure it out. Let's see. It would be bent. So Mink, to answer your question, 2 bonds, 1 lone pair of electrons, aka non-bonding, tells us that this is a bent shape. What's 2 plus 1? 3. The hybridization is sp2. What's 2 plus 1? 3. So when you look at this problem right here, it's sp2 hybridization. And it has a bent shape, okay? A bent shape. Any questions? Let me do nitrogen. Nitrogen. Oh, and we got to get into resonance also, y'all. Yeah, we're going to do resonance in a second, but let me do nitrogen. N2, okay? So let me erase this up here. So that way you all can see how triple bonds work. Okay. Triple bonds, again, are just like any other element, okay? It's just like any other element. So you've got nitrogen, N2, 10 valence electrons. I don't even need to do the math. It's 2 times 5 to give us 10. So now I've got the first nitrogen coming in was 2. Oh, wait, 2, 3, 4, and 5. The next nitrogen is going to come in also with 5. 1, 2, 3, 4, 5. Now, watch this. Let me zoom in so y'all can see it. See it. Each nitrogen must have how many? We've been saying this all along. 8. So I'm going to pull 2 from this side. Oh, because let me show you why I'm pulling them. This nitrogen on the left has 2, 4, 6. This nitrogen on the right has 2, 4, 6, but they both need 8. So therefore, I'm going to pull 2 from the top right here and just drag them to the middle. Now the nitrogen on the right has 2, 4, 6, 8, but the nitrogen on the left still only has 2, 4, 6. So the nitrogen on the right is going to have to do what? Give up its 2 as well. So now you're going to take those 2 away from the top and drag them to the middle. And now you've got your kaboom, triple bond. Yes, Jaden, it has 5 valence electrons, but you got 2 of them. Deuce, 2, double element, okay? So you've got to make sure that you say 2 times 5, that's going to give you the 10. So when I redraw this out, there it is right there. Oh yeah, honey, a triple bond is, woo, it has a magnitude of energy, it's unstable. Okay, now again, this is linear, and because it's linear, it's sp. Yes, I can explain about the linear, yes. Okay, so here it is. Linear just means you got 2 elements. Y'all, I need to bring my little toys out where I can show you how this looks. But linear just means you've got 2 elements that are coming together. Okay, you only have 2 elements. Now, if you put a third one up in there, it's just going to be a different situation. But when you have 2 elements, it is linear, okay? 2 elements off the gate is just linear. And to answer your question, you said, but why hybridization? Right here. But how you know it's linear, because you have 2 elements attached to each other and sp hybridization. Here's a pattern that you want to know, okay? Look at this right here. You see this? This is the chart. If you have 2 bonds, what's S plus P? I mean, what's 1 plus 1? You got 2. I look for patterns, okay? sp hybridization just simply means you have 2 electron groups, okay? 2 bonds, 2 attached to each other. If I say sp2, that means I have 3 bonds attached. What's 2 plus 1? 3. And now I understand why we have to know this, because this helps to predict how drugs interact with your body. You know, we can't say the D word. How drugs interact with your body. And so when we talk about chemical bonding, this whole process, it's just like, why we got to know it. But if you're going into the medical profession, this is understandable on a molecular standpoint. Like if I wanted to get really technical and say, how do these atoms affect each of my cells when I take Tylenol, or if I take an asthma pump, or if I take whatever, this explains all of that. Now, I know y'all probably not even caring about none of that, but that's the whole goal behind this. Okay. Now, to answer your question about the bonds and all that good stuff, you've got phosphorus, right? Phosphorus has 5 valence electrons. And so 1 times 5 gives you 5. And then for fluorine, it's in group 17. So 5 times 7 is 35. Yep, this is going to be a big one right here. What's 35 plus 5? 40. Now, I'm not getting ready to do all that pre-work, okay, like we were doing before, because we're getting ready to draw the picture on out, okay? Because the time is going by fast. So I'm going to put this in the middle. The element that's going in the middle obviously is phosphorus, even though fluorine is the most electronegative element, and those elements that are electronegative, the most electronegative goes in the middle. You got 5 of them though. You got 5 of those fluorine atoms. They can't all hang out in the middle. So you're only going to put phosphorus. Plus, it's just one phosphorus surrounded by all the other ones, okay? All the other fluorines. So phosphorus is coming in with 1, 2, 3, 4, 5. Now, I'm going to bring in each of my fluorines, okay? So here we go. Fluorine is coming in with 1, 2, 3, 4, 5, 6. I'm going to put the extra 7th one right there. And I need some more space, so here we go. Let me keep going. The other fluorine, 1, 2, 3, 4, 5, 6. The extra one, 7th one is going right there. The third one, 1. See, I just drew that one in. 2, 3, 4, 5, 6, 7. Man, we got 2 more to go. Here is the next one. 1, 2, 3, 4, 5, 6. Well, wait a minute. Where the extra one was going to go? And we're just going to say, hold the line, okay? Hold the line. So far, you've got 4 fluorines on this one middle atom. Here's where it gets to be what's called an expanded octet rule. I'm going to draw another one out here. So I actually need to scoot one of these fluorines over. I'm just going to draw a line right here, which represents a pair. Okay, so that's already 2 right there. That's why. But you know what, too? This is why we do the math up front. You see this 40 right here? That's why we do this up front, so that you can make sure that the math that you have equals what your picture has. So we're going to count it again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. You have 40. How many bonds are attached? Let's establish that. How many bonds are popping off of phosphorus? 1, 2, 3, 4, 5. This part is still true, 5 bonds, but there aren't any non-bondings. So 5 tells me sp3d. And you know what? PCl5 is drawn the same way. Just replace the fluorines with chlorines because they're in the same group. So this is sp3d hybridization. And the shape, let's figure out the shape. Okay, 5 and 0, 5 and 0, 5 and 0. Let's go up here. Trigonal Bipyramidal. Trigonal Bipyramidal. sp3d hybridization.